Okay, welcome back. Lesson 32, Introduction to Graphing. This is a very important segment, and you'll see it more heavily in my beginning and intermediate algebra courses on iTunes U if you haven't found those already. But it's good to give you a light intro to graphing here in pre-algebra. So let's dive in. The rectangular coordinate system and paired data. Phase 1. I want you to make sure you familiarize yourself with the following terminology: ordered pair, origin, quadrants, x-axis, and y-axis. So you see I have it drawn here. Let's talk a little bit about it. Okay, so your x-axis is your horizontal axis. Your y-axis is your vertical axis. You might want to just kind of note to self there. So y-axis is vertical, x-axis is horizontal. Because some people, believe it or not, accidentally mix up the words vertical and horizontal. Okay. Your quadrants, you can see they are labeled, so they go counterclockwise. Quadrant 1, quadrant 2, quadrant 3, and quadrant 4. You can see that origin is labeled 0, 0, so origin is right here, and its coordinates are 0, 0. Origin is where the x-axis and the y-axis intersect. Okay. Then we get into ordered pairs. Now I do want to make a little note about ordered pairs. Ordered pairs are of the form x comma y, and you might be thinking, what do we do with an ordered pair? Well, we plot them for starters, and then it gets a little deeper. Now I clipped in a little Wikipedia history here for your reading pleasure. The rectangular coordinate system is otherwise known as the Cartesian coordinate system. And I'm not going to read the whole thing with you, I'll let you read that, but I think this is important here. René Descartes, I mean, we're talking 17th century René Descartes, revolutionized mathematics by providing the first systematic link between geometry and algebra. Using the Cartesian coordinate system, geometric shapes such as curves and lines can be described by equations, algebraic equations involving the coordinates of points lying on the shape. So later down the road in my college algebra course, you'll see we'll be able to graph x squared plus y squared equals 4, and we'll be able to see that will give us a circle of radius 2, centered at origin. So it's neat to make that link between a geometric shape and an algebraic equation. Okay, let's continue a little further. Phase 2, make sure you're comfortable plotting points. Notice on the graph below where the point 4, 3 is located. So it's like over 4 from origin. Okay, so you start at origin, move over 4 to the right, up 3. So I like to read that as 4 to the right, up 3, starting at origin. Okay. So we're going to plot points here in a moment. So take a moment to plot the following points. You may want to hit pause right now. Okay? So maybe hit pause, try it on your own. But now I'm going to dive in and do it with you. So -3, 4. So that means 1, 2, 3. I'm going to go 3 to the left and up 4. 1, 2, 3, 4. So I'm going to land right here, and I'm going to call that A. Okay? 0, so -3, 4 lands in quadrant 2. Let's practice writing our quadrants. Quad 2, quad 1, quad 3, and quad 4. Okay? 0, 3, where does that land? Well, that lands right on the y-axis. There's our y-axis, there's our x-axis. So 0, 3, 1, 2, 3, that just means up 3. Okay, and I'm just going to write B. That way when you're checking your solutions, you'll see if you agree with me. 5, -6. 1, 2, 3, 4, 5. That means to the right 5, from origin, and down 6. 1, 2, 3, 4, 5, 6. Boom, right there. So we'll call that C. Okay, and then 4, 0. Well, gee, that's right on the x-axis. Okay. And -4, -5, so back 4, down 5. Now, believe it or not, some of you may be thinking this is too easy for you, but believe it or not, some people have problems plotting points. So you want to make sure you're comfortable with that before we go any further. So I just have a general recipe here. In general, when you're plotting the point x, y, you're going to move x units left or right, depending on the sign, and then move y units up or down, depending on the sign. So if x is positive, right if x is positive, left if x is negative. So that's just a little side note there for you. Okay, let's move to the next slide. One more time, plot the following points. And you might want to hit pause again, but I'm just going to go through and plot all these for you. 2, 1. And in fact, you know what? Let's just label these A, B, C, D, E, F, just so when you do your self-check, you got it. So 2, 1, that's over 2, up 1 right there. So I'll call that A, location A. -3, 4, so that's back 3, up 4 right there. And we'll call that B. 5, 0 is right here. And we'll call that C here. Could even put a little 5 in there if you want. 0, -2, that's right here on the y-axis. That's point D. So you'll get, real comfortable with sort of doing that in your head eventually. 1, -3, that means right 1, down 3. Okay. So I'll go right 1, down 3. And that'll be point E. And then -4, -5. So that's back 4, down 5. So that's back 4 and down 5. That's the way I like to think about that. And that's F. All right. Hope you're getting comfortable there. You saw that in real time, and of course you see the answers here. Order is the key word in the ordered pair. The first value always corresponds to the x value, and the second value always corresponds to the y value as a matter of convention. So just make sure you're comfortable. All right, let's head to the next slide. Completing ordered pair solutions to a given equation. An equation in 2 variables, such as 3x plus y, so you have 2 variables, x and y, 3x plus y equals 9, has solutions consisting of 2 values, one for x and one for y. For example, x equals 1 and y equals 6 will satisfy that equation, because if x is replaced with 1 and y is replaced with 6, we get a true statement. Let's check it out. Is it true that 3 times 1 plus 6, so notice I'm putting something in for x and something in for y, and seeing if it satisfies the equation, equals 9? Well, yeah, 3 plus 6 does equal 9. So that checks out. So in other words, the ordered pair 1 comma 6 satisfies that equation. You might be thinking, well, how many ordered pairs can I find that satisfy that equation? And it turns out there's an infinite supply of them. We're going to see that in a moment. In general, an ordered pair is a solution of an equation in 2 variables if replacing the variables by the values of the ordered pair makes a true statement. Okay, let's explore further. Here I give you what's called a linear equation in 2 variables. Provide at least 3 ordered pair solutions to this equation. Now, if you're just brainstorming out, and then I say, how many are there? How many ordered pair solutions are there, and what happens if you plot them all? Now, let's kind of organize our thoughts here. In fact, let's organize our thoughts in a table. X, Y. You give me an X and a Y that satisfy this. Well, you might be looking at it thinking, okay, well, 8 minus 1 makes 7. Okay, so if X is 8 and if Y is 1, that'll work. Let's think out of the box, What if X were 1? What would Y have to be? -6, right? How come? Because 1 minus -6, see the double negative, makes 1 plus 6, which is indeed 7. So, keep thinking. What if X were 7? What would Y have to be? 0. Okay? And so on and so forth. And you could provide more than that. The question is, what happens if you plot all your ordered pair solutions? There's something special about where they lie on the grid. So, okay, 8, 1, that's right here. 1, -6, so let's see, over 1, down 6, that's right here. 7, 0, That's right here. And you start to think, maybe they're in a line. Well, let's fill in blanks a little more. What if x were 4? What would y have to be? Well, -3 if you do the math, right? Because 4 minus -3 makes 7. Let's plot 4, -3. So over 4 down, aha! And you're starting to see that indeed these points are collinear. So in fact, let me grab this tool. Let me grab my line tool and see if I can connect the dots. Yep. And then what we usually do, or what we do, is we'll just put arrows on the ends of that to indicate that goes forever in both directions. So, long story short, you get the graph of a line. I'll just type that up. Okay. Let's try another. So now we know how many ordered pairs are there again. Let's say that again. Infinitely many. So the infinitely, writing in cursive there, many. So there's infinitely many ordered pair solutions to this given equation here. And if I plot them, they better end up, and here's a good word, they better end up collinear, right, in a line, lined up. Provide at least 3 ordered pair solutions to this equation. And now, you could hit pause, but you might not give me the same ordered pairs that I'm thinking of. But, okay, so let's see. Well, clearly if x were 3, 2 times 3 would make 6, and y would have to be 0. What if x were 6? What would y have to be? That's the way I like to think about it. Well, 2 times 6 makes 12, and 12 minus something would have to make 6. Well, it have to be 6, right? And it's like, okay, well, what if x were 0? And 2 times 0 makes 0, but then y would have to be -6, right? And if you need to write it out, write it out. Is it true that 2 times 0 minus -6 makes 6? So in other words, if you need to check all of these ordered pairs to see if they satisfy the equation, you can plug and chug to see that they're true. All right. Now, it doesn't say to graph them, but indeed, these are 3 ordered pairs. Now, what I like to do, just as that visual check, like I said, and I'm just going to do a rough sketch, would they end up collinear? So 3, 0, 1, 2, 3, that's right here. 6, 6, 4, 5. 6, I'm just doing a rough sketch in my mind just to see that they're collinear. So over 6, up 6, and then 0, -6, 1, 2, 3, 4, 5, 6, that's down here. And indeed, all those points are collinear. Okay? So, and like I said, if I snip the graph paper in there, that'd be easier to see. Okay, hope that helps. Let's move to the next slide. And let's kind of summarize. So it turns out a linear equation in 2 variables is an equation that can be written in the form ax plus by equals c, where a, b, and c are real numbers, but a and b are not both 0 at the same time. So examples of some linear equations are this one, and this one. It turns out that y equals 8 is, if we graphed it, would be a horizontal line, and 3x equals 4, if we graphed it, would be a vertical line. But we'll talk more about that in a moment. Every linear equation in 2 variables has infinitely many ordered pair solutions. Since it's impossible to list every solution, we graph the solutions instead. The pattern described by the solutions of a linear equation makes seeing the solutions possible by graphing, because all solutions of a linear equation in 2 variables correspond to points on a single straight line. If we plot a few of these points and draw the straight line connecting them, we have a complete graph of all the solutions. So, for example, and I took a snippet from the Martin Gay textbook here. If I wanted to graph x plus y equals 5, I could plot a few ordered pairs, say 2, 3, 0, 5, and negative 1, 6, that satisfy the equation. And like I said, connect the dots and indicate the arrows at the ends. Okay? So that indicates that all ordered pair solutions to that equation must lie on this line. Let's go a little further. Try some of this on our own. Let's summarize the procedure for graphing a linear equation in two variables. First, you find three ordered pair solutions. Connect the dots. So graph the solutions, connect the dots, draw a line through the plotted points. Sounds easy enough. Let's try. So 2x minus 3y equals negative 6. I always just like to kind of organize my thoughts in a little, some people call it a t-table because it kind of looks like a t. It's an xy table. All right, well, let me think. If x were 0, what would y have to be? I always like to put something in for, put 0 in for x and then put 0 in for y and do some figuring. Now, if you don't like to play mental math, you could write it out. So let's write it out. 2 times 0 minus 3y equals negative 6. Well, 2 times 0 is 0. So you end up with just the statement negative 3y equals negative 6. Well, in that case, y would have to be 2. So if x were 0, y would have to be 2. Okay, well, what if y were 0? What would x have to be? Well, we could do the mental math, or perhaps we should write it out. 2x minus 3 times 0. This is just me kind of doing the mental math, but writing it out, equals negative 6. Well, 3 times 0 is 0, so that's just going to wipe out. 2 times something makes negative 6. Well, gee, x would have to be negative 3 in order for that statement to be true. Okay, so now we found two ordered pairs. It might be hard mentally to find the third, but here's a trick. I'm going to show you the trick. So 0, 2, let's just plot that. 0, 2, that's right here. Negative 3, 0, that's right here. Well, I can connect the dots. And then you might notice something, and I'll do this in another color. You might notice, hey, if I rise 2 and run 3, and then rise 2 and run 3, I'll find another point. And what's the coordinates at that point? Well, let's count it out. 3, 1, 2, 3, 4. 3, 4, aha. So you can kind of visually figure on a third point if you needed to. 3, 4. And you can check it, Check, note to self. Is it true that 2 times 3 minus 3 times 4 makes negative 6 equals negative 6? Well, does 6 minus 12 make negative 6? Yep. So in other words, it's easy for me to check that that ordered pair satisfies the original equation. All right, hope that helps. So let me go back to my black color here. Right, so the red was just me illustrating the rise and run pattern. The black is the actual line. All right, let's see if we have another slide. Yep, two special cases, vertical and horizontal lines. Graph x equals a constant and y equals a constant, where k is any real number. Well, I want to kind of help you through this. Let's think about this logically. And when you say x, you might be thinking, well, where's the other variable? I only see one variable here. That's right. And it says x is 7. That means that x is 7, despite what y is. So that means that y could be any old number, but x is 7. And what happens when you graph those points? Well, okay, 7, 1, 7, 0, 7, negative 1. Hey, gee, I'm noticing that they are forming a, big note to self, vertical line. And, you might want to devote that to heart. So if you have x equals, note to self, x equals a constant, it's vertical. And I bet you any money this is horizontal, right? But Let's go ahead and make the table. Y equals 3. That means that y is 3. Think about equals meaning is in math. Y is 3, despite what x is. So x can fluctuate. You know, x can be anything. But y is always going to be 3. And what happens when you plot those points? Well, -1, 3, that's right here. 0, 3, that's right here. 1, 3, that's right here. 2, 3, that's right here. And you get the point. It's forming a horizontal. As you guessed. So you can either memorize that y equals a constant as a horizontal line, shooting through that location on the 3 on the y-axis, or you could always make a table. Okay? Here I have make a rule, and we just made that rule. So x equals a constant is always and forever a vertical line. Y equals a constant is always and forever a horizontal line. Okay, and let's see if we have any more. Oh, that was our last slide for today. Good luck out there with your intro to graphing, and I'm sure we'll see more in the future.